Okay, so for this one, it wants me to graph the following functions. I'm going to graph them based on the different kinds of transformations that are happening from the parent function. This one is going left 2, down 5. So I'm going to go left 2, down 5 for my vertex. And then it is, I went left 3. Then it is a quadratic, so I am going to follow the quadratic pattern to graph it. So I go up 1 over 1 on both sides, and then I go up 3 over 1 on from that point. And I connect the points. Okay, number 2 is going up 4. And then this is stretching it 3, and then it's also going down. So instead of going up 1 over 1 like I would for a normal square root one, I'm going to go down 3 over 1. And it looks like this. It's a square root, so it only has an arrow on one end. For number 3, this one is going to start right 1. Cube roots go up 1 over 1, down 1 over 1. And there's no other change on this one, so let me move it really quick and draw. So this is a cube root function. Okay, for 4 and 5, it gives me the parent function, and then it wants me to graph the transformation on the same coordinate plane. This one's already graphed for me in blue, so I'll graph it in red. It is plus 4 on the inside, so that means it's going opposite the sign, left 4, and down 3. So these ones are marked by 2s. And then it's the same, so. Over here on number 5, it is going opposite the sign, so left 1, up 4. These ones are also doing the same thing. This one is right 3, down 1 for my starting point. Then it has a stretch of 2, so instead of going up 1 over 1, I'm going over 1, up 2, and down 2 over 1. And then I connect my points. This one is going up 2 for my asymptote. And then the vertical asymptote is still the same. It's getting stretched by 3. So starting point's still in the same spot, except it's like super skinnier. This one wants me to suppose that the functions r and s are defined for all real numbers as follows. R is the equation 2x minus 5, s of x is 4x. Wants me to find the new equation, so it wants me to find r minus x. So I'm going to write that on the left side of my equation. I have 2x minus 5, and then since I'm minusing s of x, I have subtract 4x. Then I want to combine like terms. 2x minus 4x gives me negative 2x minus 5. B is multiplying the two equations together. So I'm going to have them both written in parentheses, and then I am going to multiply, so the left side stays the same. I have 2x times 4x, which gives me 8x squared, negative 5 times 4x, which gives me negative 20x, and that is it. C, what I'm first going to do is I'm going to find r plus s, and then I'm going to plug in negative 2 for my x. So r plus s of x is going to give me 2x minus 5 plus 4x. I want to combine like terms. 2 plus 4 is 6. And then I want to plug in 2 for x. Six times 2 is 12. Minus 5 is 7. Okay, number 9 is giving me two different functions, and it wants me to write it wants me to find the division of the two functions and then evaluate for -1. So g divided by f of x is going to be -5 plus 3x squared over 3 minus 2x. Then to find g divided by f of -1, I plug a -1 for my x. So I have -5 plus 3. -1 squared is 1. On the bottom, I have 3. -2 times -1 is +2. -5 on the top, 3 times 1 is 3. 3 plus 2 is 5. Then I just want to keep simplifying on the top. I have -2 and 5. Okay, it wants me to find all the values that are not in the domain of g divided by f. These are all the things that cannot be 0 since it's on the bottom of a fraction. So I'm going to have 3 minus 2 can't equal 0. Subtract 3 on both sides. I have -2x equals -3. Divide both sides by -2, and I get x equals 3/2. Okay. Number 10 wants me to use these two functions to solve the stuff. It has f plus g of x, so I'm going to have f plus g of x on the left, 5x plus 2 plus square root x minus 1. There is nothing I can combine in these two because one is linear and one is square root. So that is as simplified as it can be. It wants me to give the domain in interval notation. So remember, when I add two functions together, the intersection of their two domains is what I have. So my domain for f is all real numbers, because anything can be plugged in for that x. My domain for g of x is going to be x minus 1 greater than or equal to 0. So then I would need to solve that. X greater than or equal to 1. So the overlap of these is x greater than or equal to 1. I want to give this an interval notation. So this is 1. I can include it all the way to infinity. Okay. F times g of x is where I'm going to multiply my two equations together. So I have 5x plus 2 in parentheses times the square root of x minus 1. So just like on the last one where I multiplied them together, I'm going to multiply these two together. So I have f of g of x. Then I have 5x times square root x minus 1. And then I have plus 2 x square root of x minus 1. Again, it wants me to give the domain. When I'm multiplying, again, my domain is the intersection of the two. So this is the same domain, 1 to infinity. Okay. Number 11 gives me two functions, and it wants me to do function composition. So u of w of 7. So that means I am plugging in w for the x's in u and 7 for the x's in w. So what I'm going to do is I'm just going to first do u of w of x. And instead of x squared, this is going to be plugged in right there. So I have square root of x plus 9 squared plus 6. This will simplify to just x plus 9 plus 6. It'll simplify one more time to x plus 15. Then I just want to plug in my 7. So I have u of w of 7 equals 7 plus 15, which gives me 22. B is working the same way, except this time I am going to take this and plug it in for my x on W. So I'm going to first find W of u of x. So I have the square root of x squared plus 6 plus 9. I want to rewrite this. So I have W of u of x equals the square root of x squared. I can only add the numbers right there, plus 15. Then that is as simplified as I can go. So then I'm going to plug in my 7. So I have W of u of 7. Going to replace my x with 7. 7 squared is 49. (49) plus 15 is 64. 64 is a number I can take the square root of. This is 8.